good morning. Today we're going to continue with solving three equations with three variables, finding the intersection of three planes. So I hope that you have the 8 cases that I showed you yesterday handy before we start, so you can look and see. So let us have example 1. I have the equation of 3 planes given to me, and they want us to tell which case is this, and if there is any solution I can find or not. When I have a question like this, the first thing I would do, I will look and see if there is any equations that are multiples. In here, no equations are multiples. But the normal vectors of the 3 equations of these 2 equations are the same, or scalar multiple. So if these 2 normal vectors, n1 here and n2 are scalar multiple, that tells me that these 2 planes are parallel. So I can tell that these 2 planes are parallel like this. The third one is not, the normal vector is not scalar multiple of any of those, and of course the whole equation is not a scalar multiple, so this plane actually will cut these 2 planes. So it will be something like this. And it will be 2 parallel planes and a plane that cut both of them. And this is actually was case number 6. So this is inconsistent and no solution. There is nothing is common among the 3 planes. 2 parallel and 1 cut them. Okay? So this is how we do. We look first if there is any scalar multiples in the normal vectors or in the equations, and see if they are parallel, coincident, what is that case, because they will save us a lot of time and we can solve it in a few seconds. So what about this? X plus y plus z equal 5, x plus y plus z equal 4, 2x plus 2y plus 2z equals 10. When I look at this, I find that these 2 equations are scalar multiple. That means these are 2 coincident planes. So 1 and 3 are the same plane. And this one is the normal vector is a scalar multiple of the normal vector. So this plane is parallel to both of them. So this is this case. I don't remember what number was that case when we have to, that's case 8. Case 8, no solution. Okay, nothing is common among the 3 planes. Okay, now let us do this one. X minus y plus z equal 2, 2x minus y plus 2z equal negative 9, 3x plus y minus z equal negative 2. When I look at this, nothing is parallel and nothing is coincident. So this tells me that I am going to have either case 1 where they intersect in a point, or case 2 intersect in a line, or case 5, where each of the two planes intersect in a line, and we call this looks like the lavash gris cheese. So either 1 or 2 or 5. Now we cannot tell which one until we really actually solve. So those are the 3 cases, and we're trying to solve. We are going to use the method of elimination. So we can multiply this by 2 and get rid of the x's. Then we're gonna multiply this by add these 2 and get rid of the y's. It will be a lot of work if we try to do it this way. So we are going to do elimination, but in a different way using matrices. Matrices is a method to solve. We can use a method to solve 3 equations with 3 variables, or 4 equations with 4 variables. It is the same idea and the same process, but it is much easier because I'm not going to write the equation all the time. I'm just going to use the coefficients, the numbers in front of the variables. So I will write the first row, so 1, negative 1, 1, and 2. Then the second row, 2, negative 1, 2, and negative 9. It doesn't matter. I can write this first and this second. It doesn't make a difference, but I have to write the whole equation in the same row. Okay, so I wrote the whole equation in the same row. I put a line and then I put what's after the equal sign. Then I know that those are the coefficients of x, y, and z in the first equation, x, y, and z in the second, coefficients of x, y, and z in the third. Our target, there is many ways to solve this, but since it is the first time maybe to work with that, I am going to give you the most direct way. Our target is to make this triangle 0, 0, 0, and in the same order. I will make this 0 first, and I will make this 0 second, and then I will make this 0 third. Okay? How I do that? If I want to make this 0, I would multiply this row by 2 and add and subtract, and I will get a 0 here, right? So what I'm going to do, I am not gonna, the only thing that will change is this row. So I will write the first and third row as they are, 1, negative 1, 1, and 2. So write the first, the rows that will not gonna change as they are. Now I'm going to multiply this row by negative 2 and add. So negative 2 plus 2 is 0. Negative 2 times negative 1 is positive 2, minus 1 is 1. Now negative 2 minus plus 2 is 0. Negative 2 times 2 is 4, plus negative 9 is negative 5. Okay? This is the first thing. Now our target is to make this 0. So 0 here, 0 here, then 0 here. So I'm not going to change anything in the first and the second row. I will write them first. Three, 1, negative 1, and negative 2. Now I will use the first row to make this 0 because I cannot use this one because it has a 0 here. So I cannot have a number multiplied by 0 to give me negative 3 and add. So I have to use this row. So how I do that? I will multiply this row by negative 3 and add. So negative 3, I wrote the row as it is, I didn't change it. So I will multiply here by negative 3 and add, then I will see what I will get. So negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 1 is 3 plus 1 is 4. Negative 3 times 1 is negative 3 plus negative 1 is negative 4. Negative 3 times 2 is negative 6 plus negative 2 is negative 4 as well. Okay, so we succeeded to make this a 0 and this a 0. Now I want to have this to be a 0. Which row I use to make this a 0? If I use this row again to make this a 0, I will ruin the 0 that I suffered to make. So I cannot use this row again, I will use the second row now. So what I do, I multiply this second row by negative 4 and add. So nothing gonna change in the first and the second row. 0, 1, 0, negative 5. Now the only change will happen in the third row. So negative 4 times 0 is 0 plus 0 is 0. Negative 4 times 1 is negative 4 plus 4 is 0. We are doing well. Negative 4 times 0 is 0, minus 4 is negative 4. Very good. Negative 4 times negative 5 is 20. 20 minus 4. 20 plus negative 4 is 16. Okay? So once we reach that we have 3 zeros here, we succeeded and now we can solve. Remember, those are the coefficients of z, x, x, y, z. So those are the three equations. I can write that negative 4, so now I can say that negative 4z equals 16. So z equals negative 4. Now I go to the one on the top of it. I can say that 1y, so 1y plus 0z equal negative 5. So 0z is gone, so y is negative 5 actually. Okay, now we go to the first equation and we substitute. So 1x minus 1y, which is minus negative 5, plus 1z, which is 1 times negative 4. I will write it in full. I will write the whole equation so you can understand. X, from this equation, x minus y plus z equal 2. So x is what I need to find. It's 1x minus 1y plus z. Y is negative 5, so minus negative 5, so plus 5. Z is negative 4 equal 2. So x equal, this is 1. We send it to the other side, so it becomes 1. So we found the point of intersection. So we get the first case where the three planes intersect in a point because we were able to find the point of intersection, and the coordinates of these points are 1, negative 5, and negative 4. Okay, this is how we do this if it's case 1 or 2 or 5. Alright, I'm going to give you another example. I don't think I have any more time, so I will go in the next video. See you soon.